Hey Math 20-1 students, we're going to look at lesson 4.1, which is graphical solutions of quadratic functions. Well, in this part of the unit, we're looking at the difference right now of quadratic functions and quadratic equations. Quadratic functions are written in the form y equals, for example, 2x squared plus 5x plus 7. So this is standard form, but as you can see, you have the variable y and you have the variable x. So what you're doing is you're graphing it and you're talking about the characteristics such as the x-intercepts, the domain, the range. You're looking at all the points. Versus a quadratic equation is where you go 2x squared plus 5x plus 7. So you still have the same right side, but the left side will be 0. You're going to replace your y with 0. Or you solve to make y 0. So if there is a number here, for example, if you had 5 equals 2x squared plus 5x plus 7, you would move this 5 to the other side to make one of the sides equal to 0. So the equation is, a quadratic equation is where you are solving for x to find the x-intercepts. So when you guys had linear equations last year, you would replace y with 0, and then you did 2x plus 7, and then you would move the 7 over to become negative 7, and then you divide both sides by 2 to get x by itself. Well, when you have x squared equals something, it's a lot more difficult. So we have to actually look at different ways to solve for this x when the power is 2. You can't just get rid of it when there's more than one x. So I'm going to show you strategies in this unit or in this part of the unit to be able to do that. So let's look at the possible solutions that can happen. So we're looking at a quadratic equation. Well, this is what could happen. You could have a quadratic that does this, which means there are no solutions. The reason being is that it does not touch the x-axis. Or I would say x-axis. So if your graph doesn't touch the x-axis, there's going to be no solutions to the equation. Now, one route is going to be where your vertex touches the x-axis. So if you see that the vertex touches the x-axis, there will be one solution. So that means one route. A route is just how many solutions there are. Two routes would be where the graph could be upwards or downwards, but it goes through the x-axis 2 times. So this one has 2 solutions. So you can graphically figure out how many solutions there are, and then we can actually find them. So that's what we're going to be focusing on in this lesson. So example number 1, we have the manager at Susie's fashion show has determined that the function 600 minus 6x squared, so I'm going to rewrite that into standard form. So when you're in standard form, this is your y-intercept. So that's going to be important because that can help me figure out the graph of it. So what I'm going to do is put that into my graphing calculator. Negative 6x squared plus 600. Now you're going to have to change your window. We know the y-intercept is 600. So we're going to have to make sure that we go up to and maybe even higher than 600. So let's go from 0 to 1,000. So we'll graph it. And as you can see, this is a nice parabola right here, okay? So what I care about now is where it touches the x-axis. So I'm going to go slightly below as well. I'm going to go up to negative 100 for the y, just to be able to see that the x-axis. And for x's, I'm going to go from negative 15, just so it doesn't cut it off as much, to positive 15. then I'm going to graph it. So what I care about is where the graph touches the x-axis. And as you can see, there's one there and there approximately. So to find it graphically, you're going to always go second trace. You're going to go to number 2, which is 0. You're going to move your cursor to your x-intercept as close as you can to it. I'm going to move to the left of it, press enter, and then to the right of it, press enter, which would be approximately there. Press enter, enter again, and you should see that the x value is -10 and 0. So we're going to write that down. So what you want to do is create a sketch of this. So we know that our graph is going from 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, -10 to +10. We know that it has the x-intercept at -10 and +10. I just found that. And then we know that it's going to hit to the top at 600. So we want to draw that parabola shape as best as possible, like this, with arrows showing that it does continue. Now, I'm going to find the next one as well, but I know it kind of looks symmetrical, so I know that it's going to be the same on the other side, but it's going to be +10, but you should still always try to find this with your graphing calculator by going second trace, number 2, move to the left side of that x-intercept, which means that y is positive, press enter, and then go below the x-axis by shifting right until you're in the right bound. Press enter and enter again. As you can see, the 0 is 10. So I know that these are my solutions. And we can rewrite it as x equals +10. Okay, so we know that we can increase the price $10, or we can decrease, that's where the negative comes from. Decrease the price by $10. So that would be -10. And that will give us the, it says, that will give us 0 revenue, because what we did was we replaced our revenue with 0 in order to solve this. So R of x was replaced with 0, and this is the equation that we were actually solving for.